So welcome back, ladies and gentlemen. Again, this is Thursday, February the 18th, and this lesson is the introduction to our next unit, Unit 2, on functions and quadratics. This is a typically difficult concept right now, and I just want to give you the textbook reference. It is chapter 1 of your text. You might have to refer to that. If you have some of your grade 10 math notes as well from the quadratic units, I do encourage you to actually look at them as we go through it. This is just a really preliminary lesson. At any time, feel free again to pause the video and ask questions or research it yourself. And then when we come back to the classroom, you can definitely ask it. So this class, believe it or not, this word functions, you've actually been doing all along since grade 9. We just didn't use that word, right? And basically, everything is called a relation. Basically, something that is relating to other concepts. So relations, it's actually kind of hard to give you the definition. Okay, so I'll actually give you the definition of a function first. A function is, for every x, there's one y. Some of you are going to find this a little weird. That's the definition of function. For every x, there's one y. So it's probably better to actually take a step back and also show you examples. What is x, y? A lot of you have seen this before. Notice some of you are recognizing this is related to what you did in grade 9 and grade 10. These are coordinates, right? These are coordinates. So we first have to talk about this before I can even talk about the definitions, right? And it's probably better with the examples to explain what they are, because what we're trying to say for this x, which again in science class you know is as the independent variable, the y value is the dependent variable. Y then depends on that x. In grade 11, it's a little easier to talk about in another way. X values are also known as inputs. And when you put it in a rule, let's say like a program or a definition, the y value is its output. A lot of people still understand this. Finally, I know it's going to seem weird. The x values are also known as the domain. And the concept that I try to share to my grade 11 students is kind of like a noun. It's like a verb. Actually, it's a noun. And the y value is called its range. All of these mean the same thing, and this is probably the best way. And also some of you are realizing, Mr. Chen, maybe you might know that this is dealing with a Cartesian plane. Technically, we're only dealing with 2 dimensions. In 3 dimensions, that's what you're going to explore in calculus and vectors, right? So this is why this is there. So let me show you an example of a function. And notice what I'm trying to show you. I know it seems weird. This is called the table of values. Again, I don't know actually what the rule is that would give us this answer, but I'm just trying to recognize this definition. So in some sense, this introductory lesson, it's just kind of ways actually exploring these 2 words. And again, I know I haven't defined them yet. So let's give you this table of values. For these x values, let's just say we got 9, 7, 5, and 3. And basically the question is asking, what is this? And this is a function. Why? Because for every of these x values, there's one y value. Right? For every input, there's one output. Now, if you look at the handout, a function is a special type of relation, which is a set of ordered pairs in which for every value of x, there's only one value of y. It gets kind of convoluted, right? It takes so long, but I just shortened it out for us a little bit easier in English. For every x, there's only one y. And this is a good example. Everyone see that? This one opposite that. So what is a relation? A relation is just simply any ordered pairs. That are related. Unfortunately, I'm using the word related and relations in this. This is actually poor English, right? So there's a maxim that kind of says, all functions are relations, not all relations are functions. I'll say that again slower. All functions are relations, not all relations are functions. Let's explore this further. This is what a lot of you have seen. Let's just look at these two. Here's another way to represent a function. This is your first time really seeing this, but maybe some of you might remember in elementary school or middle school. This is called set notation. So we have a table of values. Hopefully it's okay that I'm using TOV. This set notation, notice what I'm going to do. I'm just going to maybe do 1, 3, 3, 7, and 4, 3. And again, this is like a yes or no question. What is this? Is this a function or a relation? Well, if we take a quick look, 1 outputs 3, 3 outputs 7, 4 outputs 3. This is a function. And again, the reason why this one is a function is because for every x, there's one y. Notice in this example, the outputs happen to be the same. It's like thinking of doing a test, right? If one classmate gets perfect and another student gets perfect, that's fine. That's a function. It can happen. It can happen. What would not be a function? Let me show you. Let's just say we'll do that example. Let's say that we had a math test. And notice this is impossible, right? But let's pretend that John got 100%, but then John, the same kid, same student, got 0. What? Got perfect and got 0? Don't get me wrong, it could possibly happen. Maybe he cheated or some kid erased his name and put his name on it, but actually submitted a test. It's possible to happen, and it is a relationship. But this, getting 100% perfect and 0, although this in mathematics, in this context, this one would not be a function, right? Why? Because John, although it could be a relation, some weird way happened, getting perfect and 0, this is not a function. It's a relation though. I mean, it's a weird relation. Like, who would want to get perfect and 0 on a test? What does the teacher do? How do I record this? Right? So this is not a function. I'm going to erase this example because I have to. Any questions so far? The whole big idea is this. For every x, there's only one y. There's another way to show this. So this is called set notation. And again, notice the examples I think are better than actually looking at the definition over and over again. This one I'm showing you again is probably new to a lot of you. And this is called a mapping diagram. The numbers or any of the values that are in these kind of circles this always relates to the inputs or the x values or the independent variables. And these are the ranges or dependent variables or its outputs. The emphasis of this, notice I'm using blue chalk here, it doesn't have to be blue, but I am showing you how this 3 maps to or outputs 5. So some students would like to know, well, how would I translate this mapping diagram? This is really new for some. So watch what I'm going to do. I'm going to show you this mapping diagram as a table of values. And again, I know it made it simple, just to show you. This 3 outputs 5. This 3 also outputs 7. Some of you should be suspicious, but that's what that means. And this 4 outputs 9. Now again, one more time, some of you would like to ask you, but Mr. Chen, how are you making up these numbers? And notice, we actually, at this moment, we don't care about the rule or its operation. All I'm actually just looking at is what goes in and what comes out. I actually don't care about the pages right at this moment. Eventually we will care, because some of you I think are going to understand. Or let's just do this thing again as a set notation. And I apologize if I'm going off screen. I probably already am, who cares? So I just did a table of values of this mapping diagram, and I did a set notation. And so maybe, a lot of you understand. Can I ask a question here? I know it seems obvious. Can someone please, maybe from the class, is this a function or a relation? Or I don't know, who cares? Any volunteer? You have 50-50 chance. If you guess wrong, I'll just tell you the answer. Daisy?
Is it a function?
It is not a function. Would you like to try again? It's a relation. And the reason why The reason why this is not a function, let's remember this is not a function, is because the golden rule, for every x there's only one y. In this example, notice this 3 outputs 2 possible answers. Let's pretend, I apologize, I don't mean to make this sexist or insult you, but it's true. Those old comedies, rom-coms or whatever, maybe you've seen a series that one guy's trying to date one twin and another twin, he has like a rose or something, and he's got to keep track, and he's trying to date 2 girls at the same time, or the girl's trying to date 2 guys at the same time. I'm just trying to make it general, I don't know, whatever. But that's when they're funny, right? And they're trying to meet up and everything. I don't know, I'm dating myself, maybe some of you might remember the show Community, and they're trying to figure out who's going on, Abed or Troy or whatever, I don't know. Anyways, this is the whole point. It's possible to happen, it is a relation, but in the context of math, this is not a function, because these 3's are outputting 2 answers. Everyone see that? Again, it could possibly happen. It just means it's not a function. So this is not a function because for this example, the x's are giving us 2 possible answers. So again, it's not saying it can't exist, it's just the idea of a function. So what I'm trying to really also show you in this lesson is a couple of ways of describing it. The last one, although there is a final one, but we'll do the final one on our remote learning, and I have to erase all this. Our final one, and I think some of you are saying from the table of values, is graphically, and I think this is already a hint. So graphically, here's another way. So one more time as a recap, just to make sure. We looked at a table of values, we looked at the set notations, and we looked at the mapping diagram of functions and or relations. I'm going to do 2 sketches on a Cartesian plane. Notice we're just doing sketches. And notice there aren't any numbers here. So my question is to you, is this a function or is it a relation? Is this a function or is it a relation? So this one's a little bit trickier to answer. Is there, the definition for a function means that for every x there's only one y. When we're giving graphs usually like this, there is an extra hint to help us figure this out. And this hint, and as I finish up our lesson, is called the vertical line test, or the VLT for short. A lot of kids like to call them VLT because it's easy. And a VLT basically states when you pass a vertical line through the object, or in this case, the graph. So even though there's a graph here at x and y axis, we're not looking at that, we're actually looking at the image or the instrument. If it passes through it only once, or crosses through it once vertically, then it's a function. However, if it passes it more than once, then it's not a function. That's why it's called a vertical line test. And so in this example, notice this is a straight line. And again, hopefully, I don't have my ruler anymore. We'll use my protractor. If you go from left to right or right to left, doesn't matter. Notice there's nothing here, but oh, it crosses right there, right? So the vertical line, it crosses there, right? It only crosses once. If you keep on going through the whole image, maybe let's say over here, you check over here, it crosses only once. So one more time, that's a vertical line, the orange line. So yes, this is a function because it passes the VLT, and it satisfies it. Before we continue, everyone okay? This is why some of you realize slowly, when I introduce this unit to you, you've been dealing with functions and relations ever since grade 9, because this is a vertical line. What's a vertical line? A vertical line is never expressed in terms of y equals mx v. A vertical line is always expressed as x equals. Notice, this is not the dependent variable. This is the independent variable. So some of you slowly keep realizing when you look at this object, which you've seen in grade 10, and again, it might have been a long time, last year. If we start here, so we're saying, I don't see anything, so there's no, it's not a function yet, not a function, not a function yet. And if you touch right here, you're going, well, Mr. Chan, it's touching that right, like right there. What are you talking about? It's a function, so okay. But if you keep on going over, maybe over here, this thing that I drew is a circle. And some of you say, but Mr. Chen, we learned this, and maybe Arshia knows what I'm talking about. A lot of you know that this has an equation. The equation of a circle is x squared plus y squared plus equals r squared. It definitely has an equation. What are you talking about, Chen? It has an equation. But in the context of grade 11, this one, this is not a function because it fails the VLT, the vertical line test. And some of you are slowly understanding, eventually we're going to look at equations, because these actually have equations. Like this could be y equals 2x plus 3. This one is a function. This is the equation of a straight line that you've seen before. This one's an equation of a circle, but it's not a function. And the reason why, again, because for every input, there's actually two outputs. Why? Because at this value, maybe at value of 3, let's just say, maybe this value here is, positive 7, and maybe negative 5, let's say, because it's not directly around the origin. So notice, it's still true, you have coordinates there, but in the context of what we're just trying to get across today, there are relationships experienced in math, but the big, hard challenge we have to get across right now is things are not all functions. Some of them are just relationships. And that's why I like ending off with this as a diagram, because a lot of you can tell this is a straight line. You can graph this. You can do a table of values, and plot the line. You could also do table of values or use an equation and figure that points. And that's where we're going to stop this video. It's 17 minutes to